Chapter 4, Section 4 is on congruent triangles. So by the end of this lesson, you should be able to use properties of congruent triangles and be able to prove that triangles are congruent by using the definition of congruence. So let's remember what that is. Remember, congruent is the equal sign with a squiggle over it, and it means same size, same shape. So you have corresponding angles and corresponding sides in polygons. So we're focusing on triangles for this chapter. So two polygons are congruent if and only if their corresponding angles and sides are congruent. Thus, triangles that are the same size and shape are congruent. Now, if you look at this picture here, we got a couple things going on that remind us what parts are congruent. So BC is the same length as FE because both of them just have one /E. Where like AB is the same length as ED because they have two, and then obviously the same for AC and DF. And then we have these angle measures, and they marked them with colors, but even if it was in black and white, they marked it with /Es again. So angle A and angle D are congruent, angle C and angle F, and then angle E and angle B. So property of congruent polygons. For this one, the words are really important down here. So when you see that triangle ABC is congruent to DEF, that means that A and D are congruent angles, that B and E are congruent, and that C and F are congruent. They put them in that order for a reason. And then we can connect the sides. So from A to B is the same as D to E. From B to C has to be the same as E to F. And then A to C is the same as D to F. Same thing works with this rectangle that they give us. But again, for this, we're going to focus on triangles. So again, the order really matters with the words down here. That basically tells you everything you need to know, even if you're not given a picture. So, like this problem, given PQR and STW are congruent, identify all pairs of congruent corresponding parts. So we could draw a picture of this, PQR, and then we have STW. And remember, again, the order means something. So this angle here has to be congruent to that one there because they're both first. So angle P has to be congruent to angle S. And then angle Q and angle T, because they're both mentioned in the middle, have to be congruent. And then finally, angle R and angle W have to be congruent. And then the sides that connect have to be congruent also. So in the words P and Q and S and T, and we can see that from our picture that we have here. And then Q and R and T and W. And again, you can see that from the picture. And then finally, the last one, connect the first and the last. So PQ, or PR, sorry, and SW. And there are these ones on the bottom. So let's do an example. Again, remember, order matters. So triangle ABC, so here to here to here, is congruent to triangle DBC. So if we want to mark where things are congruent, AB has to be congruent to BD, and then angle A has to be congruent to angle D, and then this angle here has to be congruent to this one here, and then finally this one here has to be congruent to this one here. Obviously these are the same, so that means these have to be the same. So once we have this properly marked, we can find the value of x. So now the x right here is pointing to this 90-degree angle. So I know that 2x minus 16 has to equal 90 degrees. So if I add 16 to both sides and then divide both sides by 2, we get that x is 53. And it doesn't ask us to plug it back in, but we could, and remember, we want this to equal 90 degrees. And 2 times 53 will give us that 106 that we just had, and then if you take away 16, you do get 90. So now the next one wants us to find the measure of DBC. So they want us to find this angle right here. Now, we know that in here is 90 degrees. We know this is 49.3. And inside of this triangle, ABC right here, all of the angles have to add up to 180. So I can find this angle here, ABC. And then because they're congruent, that means I know the measure of that angle. So I'm going to take the 180 degrees that I know all triangles add up to, subtract the 49.3, and subtract the 90 degrees that I know is there. So when we do this, we end up with 40.7 degrees. And because that's the measure of this guy here, it has to also be the measure of that guy there. So now we're going to do some proofs. To prove that two triangles are congruent, we would need to show that all corresponding sides are congruent and all corresponding angles are congruent, because that's the definition of congruent figures. Fortunately, once we get through this section, we'll learn kind of some shortcuts, but right now we have to prove that everything is congruent. So in this two-column proof, we still have our statements and our reasons. And if you look, we're trying to prove that x, y, w is congruent to z, y, w. So we're given some things. Angle YWX and angle YWZ are both right angles. So we have that. So let's write that down. Angle YWX and angle YWZ are right angles. It's given to us. And then say what that means. If they're both right angles, that means that they both have to equal 90 degrees, and that means they're congruent to each other. So we know they both equal 90 degrees by the definition of right angle. And then, because of that, we can say that these two are congruent. Because remember, we got to prove that everybody is congruent here. And this is substitution, or you could use transitive property, whatever makes more sense to you. If I can spell substitution. So far we have proved that these two are congruent. We got a couple more to go. So the next bit of information that they give us is that YW bisects angle XYZ. So we have XYZ is this angle right here. And if this bisects it, we know that that means these two have to be congruent by definition of bisect. So we're going to write the given down. Angle XYZ, and that one's given. But then because of that, we know that angle XYW has to be congruent to angle WYZ by the definition of bisect. So we're moving right along. We have two of our angles are congruent. And I'm going to make a new two-column over here because we're going to need it. So now the next piece of information they give us is that W is the midpoint of XZ. So right here is right in the middle of from here to here. So that means that those two have to be congruent. So W is midpoint of XZ. That's given to us again. And that means that XW has to be congruent to WZ. And that's by the definition of midpoint. So we have two angles and one side so far that's congruent. And then they tell us one more piece of information, that from XY is congruent to YZ. So that was given. So now we basically have two more things to prove. we need to prove that this angle here is congruent to that one there, and that this side length right here is congruent. So one of these is really easy. Because this is shared by the triangle, we know that YW is congruent to YW. And think back to our properties. This is the reflexive property. So remember, this one kind of seemed like, why the heck are we even saying this out loud? It's because we have to prove that if it makes up this triangle over here versus this triangle over here, that they are exactly the same thing. And then the last thing that we have to prove are these angles here. That angle YXW has to be congruent to YZW. And we can do this with one of the theorems that we learned in the last set of notes, the third angle theorem. So we know that YXW is congruent to YZW because of the third angle theorem. And remember, that said that if you know that two of your angle measures in a triangle are congruent, then the third one has to be congruent also, because they both have to add up to 180 degrees. So now that we have proved that all angles and all sides are congruent, we can finally say that triangle XYW is congruent to triangle ZYW. And this is the definition of congruence. Lots of work. So let's try one more. PR and QT bisect each other. We know that a couple angles are congruent and a couple segments are congruent. But we need to prove that triangle QPS, so this one here, is congruent to TRS. So remember, that means we have to prove that all three angles and all three sides are congruent. So the first thing they tell us is that PR and QT bisect each other. So that tells us that this has to be congruent to this, and this has to be congruent to this. S is the midpoint. So PR and QT bisect each other. And we can say this because it's given to us. And then from that, we know that QS has to be congruent to ST. And that's definition of bisect. But then we also know that PS has to be congruent to SR. Now, let's use our other givens. The next thing it tells us is that PQS, so this right here, is congruent to RTS, so this right here. We can't really say anything more from that, so we'll move on to the next given. QP, so this, is congruent to RT, so that. So we know QP is congruent to RT, given. So right now we have all three sides, so we're good with sides, but we only have one angle. So think back to when we first started talking about angles, we talked about vertical angles. Because these two angles here are vertical, they have to be congruent. So we can say that QSP is congruent to RST because of vertical angles. And then again, that just leaves us one angle that we have to prove is congruent. And just like the last one, we can do that with this third angle theorem that we used. So let's make a new column. We now know that angle QPS has to be congruent to angle TRS, and that's because of the third triangle theorem. And now, because we've proved that all three angles and all three sides are congruent, we can finally say that triangle QPS is congruent to triangle TRS. And again, that's by the definition of congruence. So proofs are back, but hopefully you see them now as more of a puzzle than a mystery, because you have a goal. You have to prove that all 6 things are congruent. And once you do that, you can use the definition of congruence to say that the 2 triangles are congruent. So you should be able to do 2 things. Use the properties of congruent triangles to solve problems where we found x, and then prove triangles are congruent by using the definition of congruence. Make sure you write down any questions you have, and we can go over them tomorrow in class. Have a good night.